Emma, a backend engineer, suddenly gets an alert on her phone. Production system failure. Customers can't complete payments. The company is losing money every minute. Emma opens the server logs, hoping to quickly find the issue. Instead, she sees thousands of lines of logs scrolling endlessly. Errors, warnings, tag traces. Somewhere inside those logs is one line that caused the crash, but finding it, that could take hours. Emma's situation is not unusual. In fact, it's happening in engineering teams every single day. Modern applications are no longer simple systems. They are built with dozens of microservices, APIs, databases, and cloud components all interacting with each other. Every action inside these systems generates logs. A single application can produce millions of log entries every day. So when something fails, engineers like Emma are forced to dig through massive log files just to understand where the failure actually started. The challenge is that logs are scattered across multiple services, unstructured and difficult to analyze, filled with noise that hides the real error. One common frustration engineers express is, I know the problem is somewhere in the logs, but I don't know where to even start looking. This happens because modern systems generate massive volumes of logs, and most of them are not useful for identifying the root cause. Another common observation from DevOps team is, by the time we identify the root cause, the outage has already lasted for longer than it should have. Engineers often spend hours correlating logs across multiple services, trying to figure out which event triggered the failure first. Let's look at a real industry: large e-commerce platforms. Companies like Amazon process over 8,000 orders every minute globally. Behind each order, hundreds of microservices are working together, handling payments, inventory, user authentication, shipping, and recommendations. Every one of these services continuously generates logs. Now imagine a failure happens in the payment system. Within seconds, thousands of error logs start appearing across different services. Engineers must quickly identify where the failure actually started. But here's the urgency. For companies at this scale, even 1 minute of system downtime can cost hundreds or thousands of dollars in lost scale. This is where LogSherlock comes in. LogSherlock is an AI-powered log analysis assistant that automatically detects error, finds root cause, and suggests fixes within seconds. Let's see it in action. Here, we paste production logs containing a stack trace and error message. Once we click Analyze, LogSherlock performs 4 intelligent steps. Step 1. First, it detects the critical exception in the logs. Step 2. Next, it performs root cause analysis by identifying patterns such as database connection, pool exhaustion. Step 3. It then searches historical incidents using vector database to find similar past failures. Step 4. Finally, it suggests a practical fix based on previous successful resolution. LogSherlock uses modern AI technologies to make this possible. Logs are converted into vector embeddings and stored in a vector database. When a new incident occurs, the system retrieves similar past causes using retrieval augmented generation. The AI model then generates a grounded root cause analysis and suggested fix. With LogSherlock, teams can reduce mean time to resolution by up to 50%. Engineers spend less time debugging and more time building. Before LogSherlock, Emma, a backend engineer, had to manually go through thousands of log lines whenever a system failed. Hours were spent searching for the real issue, while users kept waiting for a fix. After LogSherlock, Emma simply uploads the logs and the AI instantly analyzes them, pinpoints the root cause, and highlights the exact error. What once took hours of stressful debugging now takes just seconds. Our vision is to build a future where debugging is no longer a slow, manual process, but an intelligent and automated experience that empowers developers to focus on building better products instead of searching for errors.